All right, so today we're talking about the differential equations, equations that contain a variable and some of their derivatives. So here we've got a differential equation. We got dy dx equals x squared times y. So, or it could have been written y prime equals x squared y. Now that's an equation because it's got an equal sign. It contains a variable and it contains a derivative. Okay? So it's a differential equation. Now, an equation is a solution to a differential equation if the equation and its derivative make the differential equation true. Okay, so today we aren't solving differential equations. Today, really all we're doing is we're going to verify that things are solutions to a differential equation. So here I've got this equation, y equals 2/3 e to the x plus e to the negative 2x. I got to show that that is a solution to this differential equation, and this is a differential equation because it contains y and it contains a derivative. All right, I already know what y is, right? What do I need to find? For this equation right here, what else do I need to find? Got to find y prime. All right, so let's find the derivative of this. Y primed from what we've been given as a potential solution. Y primed is equal to what? What is the derivative of 2/3 e to the x? Addison. Hey, see? You got to remember everything from first semester. Addison, so far you're perfect. Okay? And then Ryan Kruk, I need the derivative of e to the negative 2x. Negative 2 e to the negative 2x. Because the derivative of e to the something is e to the something times the derivative of that something. Okay. I have first of all found the one derivative that I need. Now what I need to do is show that this equation right here is true. If it is, then this potential solution is actually a solution. Okay, so y primed, 2/3 e to the x minus 2 e to the negative 2x plus 2 times y, 2 times 2/3 e to the x plus e to the negative 2x. Is that indeed equal to 2 e to the x? Well, that's what we got to show, and we've got to show our work to make sure that it is indeed true. 2/3 e to the x minus 2 e to the negative 2x plus, now I'll distribute my 2 and get 4/3 e to the x plus 2 e to the negative 2x. Is that indeed equal to 2 e to the x? Well, what do we see happening? Joe Lynch, what do you see happening? If you give me one. 2/3 of them plus 4/3 of them is 6/3, or so I've accounted for that. But what about these guys? They do cancel out. One of them's a +2, one of them's a -2. Have I shown that if I'm given this equation right here, it does indeed make this differential equation true. And I think I've shown enough work that I've shown that that is indeed a solution. Are you good with that? All right. All right. That's it for that slide. We move on. Show that every member of the family of functions is a solution. Holy cow. Now, this is a family of functions because there's a C. C is some constant. C is some coefficient. And that's pretty consistent throughout the entire book, that when you see a C, it means constant. So C might be 5, C might be 7, C could be any number. Therefore, there's an infinite number of members of this family of functions. Now, we got to show that that is indeed a solution to this differential equation right here. So I can see what y squared is going to be, but oh man, how am I going to find y prime? How am I going to find y primed? Veronica, how am I finding y primed? Yes, I am. Okay, Jack Dieter, can you tell me what the quotient rule is? Right church, wrong pew. Hidden? Low D high minus high D low over low low or low squared. All right. So that's a pain. Y primed equals low 1 minus C e to the x. And what is the derivative of the top? Anybody? C e to the x minus high 1 plus C e to the x d low, and what's the derivative of the bottom? Negative C e to the x over low low, which is 1 minus C e to the x squared. All right. Holy cow. Now, I got to plug that y primed into this equation and show that this thing is true. Man, oh man, that's going to be something. Well, let's see, y primed. You know what? I'm going to simplify this a little bit. I'm going to say that y primed, I'm going to distribute this guy. And I think we're going to get C e to the x minus C e to the x squared. Minus, now I've got to do this. And when I do that, I better put this in parentheses so I remember to subtract the whole thing. I believe I get negative C e to the x. And when I do this, I think I get minus parentheses C e to the x. That quantity has to be squared. And that is the entire thing that needs to be subtracted on top. And yeah, there's probably a little simplification that can happen. Over 1 minus C e to the x being squared. Okay, that's a pain. Equals 1/2 y squared. 1 plus C e to the x over 1 minus c e to the x being squared minus 1. Wow. You know, it's not real obvious to me that these are identical. I think I got some more work to do. What's going to happen with this guy over here on the left? What's going to go away? Anybody? I think that is negative, and when we subtract a negative, I believe those are going to be canceled out. What are we going to be left with on the top? Two c e to the x over 1 minus c e to the x being squared equals 1/2. Now, I'm actually going to square this thing here. I think I might have to do that. I might have to square this. And I'm going to have, in my numerator up here, I'm going to have a 1 plus 2c e to the x plus parentheses c e to the x being squared. I'm not going to actually multiply out the bottom. I'm going to call that 1 minus c e to the x being squared. Because that gives me a common denominator on the left side of the equal sign and the right so far, doesn't it? Then minus 1. But instead of calling it a 1, I'm going to call it, well, the denominator is going to be 1 minus c e to the x being squared. I need a common denominator. And am I going to call the top, and don't write it, please don't write this, am I going to call this 1 minus c e to the x being squared, and is that 1? Yeah, I have subtracted 1. However, what I'm going to do on top is I'm actually going to multiply that out. So I'm going to multiply this out, and I'm going to get a 1. I'm going to get minus 2c e to the x plus c e to the x, which has to be squared. Well, okay, so you know what? It just is not obvious that these things are really equal. Over here on the left side, my y primed is still 2c e to the x. Over our common denominator, 1 minus c e to the x being squared. I got a 1/2. And in these parentheses, I'm actually going to subtract those fractions. I'm going to have a common denominator of 1 minus c e to the x being squared. So I'm really happy. I got common denominator left side, right side. So I like that. Now tell me about the ones. What's going to happen? Go on. Tell me about 2c e to the x. 4c e to the x. So I've taken care of it. I've combined those like terms. Tell me about c e to the x squared. Go on. That's a positive 1, and I am subtracting a positive 1 making that result 0. Hey, this cleaned up nice. And what is 1/2 of the 4? 1/2 of 4 is 2. And have I shown that that really is a solution to the differential equation? Boy, that was a pain, wasn't it? Yeah, you want one of those for homework? I'd love to give you one. All right, cool, tough one. But we were able to show that the left and right sides of the equal sign are indeed the same. All right, so we verified that's a solution. And it doesn't matter what the value of C is. If C is 5 or 7 or 9, it doesn't matter. Now, our final slide. We just verified this differential equation has a solution of 1 plus CE to the x over 1 minus CE to the x. If y is equal to 1 plus CE to the x over 1 minus CE to the x, this differential equation is true. That is a family of solutions. But what we'd like is we'd like to find C. If we are given an initial condition, we can find C. We can find a specific solution. And so when you're given an initial condition and asked to find a specific solution, that means this is your answer right here. You're just not going to have a C. You're going to have some number. Now, as I look at this, what is the y value? 2 equals 1 plus, I don't know what C is, e to the 0. And what is e to the 0? Okay, don't have to write it. The bottom is 1 minus C, don't know what it is, e to the 0, which is again 1. Do you think you can solve this and figure out what C is? By maybe cross multiplying? Yeah, you go ahead and do it. I'm going to do it, and we're going to see what we come up with as a value for C. I got that C was 1/3. Did you get C was 1/3? So our specific solution is this same thing we had before. 1 plus, but I'm not calling it C. 1/3 e to the x over 1 minus 1/3 e to the x. That is a specific solution. Can only really come up with that after we've shown that this general solution actually was a solution, verifying that was a solution. Okay, that's it for the notes. Now I'm going to give you the assignment. You're going to work on that. I got to press stop.